Hi guys, in this video we will understand cloning theoretically and practically. In this video we will learn the following concepts. What is cloning? How do we clone objects? Types of cloning. How immutable objects make our job easy while cloning. This is one of the advantages of immutable objects. What is cloning? You know, right? It is just a process of creating a copy of an existing object. So in real-time applications, we copy the existing objects to perform some operations on the copied object, not the original object. This is required, right? Because normally what will happen, I saw a couple of projects where we get objects in the file actually, that is stored in a file, and that file we will get it, we will deserialize it. That means it is serialized, the object is serialized into one file, and once we receive the file we will deserialize it into one object. So that object, after getting that object, we should not do directly changes on that object. Instead of doing directly changes on that object, what we will do is we will make it as a backup copy, and we will create one more copy of that object, and on that copied object we will do some operations. So we want to save that original object. We don't want to do operations directly on the original object. So in that case we will use cloning. So cloning is nothing but creating a copy of an existing object. So how do we clone objects? What is the process in Java? Is Java providing any way to clone objects? Yes, using clone method of object class. So we know, right, object class is a super class of all the classes in Java. So clone method is provided in the object class, so we can use that method to clone the objects. And also the class which we are cloning, let's say employee class or student class or any class which we are cloning, should implement clonable interface. That means once the class implements clonable interface, then class will become clonable, the object will become clonable. In that case, Java will do automatically the cloning using this marker interface. So we need to mark the class as a clonable. Okay, that is, clonable is a marker interface. Marker interface means generally we use these marker interfaces to mark the classes to provide certain functionality that will be provided by Java basically. And these marker interfaces do not have any methods. It is just a plain interface. That means it doesn't have any methods. Interface without any methods is nothing but a marker interface, right? Anyway, and also the class which is being cloned, let's say I am cloning employee class, employee object, that should override clone method, because anyway object class is providing clone method, directly I can call the clone method. No, here clone method is protected inside object class. That means only subclass only can able to access that clone method, right? So that's why we must override clone method. Even though to call the clone method of object class, we need to override the clone method, then inside that we need to call the object class clone method. Okay, and for example, if the class does not implement clonable interface, I am just overriding the clone method in the object class, but that my class is not implementing the clonable interface. What will happen? What will happen is, during runtime, if you try to clone it during runtime, we will get clone not supported exception. So this is one interview question. So when we get clone not supported exception, simple, if the object which is being cloned, the class, if it is not implementing the clonable interface, then we will definitely get clone not supported exception. This is how we can answer. We will see this practically soon. Okay, next. Okay, we are cloning it, fine. So we will have some types of cloning also. That means two ways cloning is done. What are those two types? We will see. The first type we call it as shallow cloning, which is the default one, performed by clone method of object class. Okay, shallow cloning. Deep cloning. So in the deep cloning, we need to write certain logic inside clone method, that is overriding clone method. Okay, So we will understand in deep what is shallow cloning and what is deep cloning. In what situations we have to use shallow cloning, in what situations we have to use deep cloning also we will understand. So what is shallow cloning? By definition, if you see, shallow cloning refers to the process of creating a new object. Okay, that is nothing but cloning. That is a copy of the original object. Okay, but with all of its field being copied by reference. So copied by reference means only the variables will be copied, not the objects. That means, let's say if you take employee and employee class, which is having a reference variable pointing to the address object, only the address variables are copied but not the address objects. So both original and the cloned object, both will be pointing to the same address object. I will show you. In other words, we can say the cloned object and the original object will be sharing the same references rather than creating new copies of those objects. Okay, we will see this. Anyway, and also object class clone method performs shallow cloning by default. This is what we need to remember. If you use the object class clone method implementation directly without implementing your own clone method, then it will use shallow cloning only. So how shallow cloning looks like? This is how it looks like. For example, this is an original employee object. Okay, I am trying to clone it. So this original employee object, if you see, it has two variables. Okay, one is employee ID. This is an int type. Let's say it is having a value of 1. The name is here string object. Okay, so initially this is how it is created. The name is pointing to the string object, which is Rakesh. Okay, now I cloned it using the shallow cloning. Okay, what happens, it created one object. This is cloned object, exact copy, but here employee ID primitive types, the variables got copied along with these values, but this is a reference type name. Reference variables are copied here, but this reference variable is only reference variables are copied, not the object. That means here this reference variable also pointing to the same old object. That means two objects sharing the same reference variables. That means two objects are sharing the reference variable pointing to the same object. So this is not good, right? In deep cloning, for example, if you modify this, if you modify through cloned object, the original object also gets modified, right? Yes. So this is how shallow cloning will be done by default. Object class clone method will be doing shallow cloning like this. Okay. Next, what is deep cloning? So in deep cloning, it refers to the process of creating a new object that is a copy of the original object. Okay, but recursively creating copies of all the objects that are referenced by the original object. Let's say employee address. Again, if I clone employee, address also will be getting cloned. I will show you that in a while. In other words, the cloned object and its nested structures are completely separate from the original object, ensuring that modifications made to one do not affect the other. We will see in the diagram soon. But anyway, clone method of object class performs shallow cloning by default. This is what we need to remember. For deep cloning, we need to write our own logic inside the overriding clone method. We will see it practically. Deep cloning, how it looks like? Here, let's say I have two variables, right? Name is pointing to the Rakesh original object. Now after deep cloning, again the reference variable name will have a separate copy, not the original object. Let's say in the shallow cloning, this name is pointing to this original object, right? But in deep cloning, even the nested objects also will be cloned. So for this, we need to write our some logic inside the clone method. Okay, so this is how deep cloning looks like. So we will see it practically soon. Are you ready? Yes. We'll go to IDE. Okay, let's start with some code. I have created one employee class to demonstrate. This is a plain employee class. It has two variables, employee ID and name, and one constructor, some setters and getters, and two string method to see the content of the object. Okay, that's it. We'll close this. Okay, so what I will do is here, first we will create one employee class. Let's say employee E1 is equals to new employee. So let's take let's pass the rule number and some name. Okay, name is Rakesh, let's say. I am done, right? Now let's copy it. Okay, e1 dot, let's say employee e2 equals to e1 dot clone. See, I am not getting the citation for clone method, but clone method is available in the object class, and each employee class is subclass of object class. So I should see clone method, right? But I am not seeing here. Why? Because the clone method is protected method, so we cannot see here. So we must override inside employee. So what we will do here is we will just override the clone method here. Okay, so what we will see is here public employee, I have to return employee object, right? Employee override, sorry, not override clone, and this one throws clone not supported exception. Okay, so I'm adding override annotation. If I make any mistakes, it will tell me am I overriding properly it or not. Yes, now we need to call the super class, that is superclass clone method. It will do cloning for us. It will do cloning for us, but if you see this, it has to be casted to employee, because by default it will return the object, right? Done, this is done. So with this, what will happen, you know, because of overriding this particular single line, because of overriding the clone method with this single line, let's say if I have hundreds of variables here, all those hundreds of variables data will be copied to the new object. It's a wonder, right? Because if this clone method is not there, let's imagine what a developer's life will be. We need to create a constructor, and we need to pass the old object, and we need to copy all the objects here. Lot of lengthy code we have to write here. But because of this I am avoiding the copy constructor. That means we need to create a copy constructor here, and we need to copy all the variables to this, right, to create a new object. If there is no clone method, we have to copy the object that way, right? But because of this clone method, our life is becoming easy, thanks to Java for providing this clone method. Okay, now two variables, okay, we can create easily, but if there are thousands of variables, hundreds of variables in the same class, then it is difficult to copy the object manually. So this clone method is helping us here. That's what we need to understand. We need to realize the importance of clone method. Okay, anyway, so okay, done, right? Clone method. Now here clone method will be visible now. Yes, it is visible. Okay, good. And this is telling something, right? Unhandled exception, type clone not supported exception. So clone not supported exception is a checked exception. So we must handle it either throws declaration or surround it with try catch. So for now I will just add as a throws declaration. Okay, done. So okay, so e2 is cloned. So e1 e2. Now if you just see the content of both employee 1 and employee 2, both will be same only, right? Both will be same. Can you see this? I told you, clone not supported exception. When we will get this exception? Because my class is not a clonable class, my object employee is not a clonable object. Why? Because I am not implementing the clonable interface. That's what we discussed, right? So we must implement clonable interface if we want to use clone method on this particular class. Okay, this is must. Now we will run it. Yes, we got, right? So we have two objects and with content, we are good, right? But by default, object class clone method, what it will do? It will do what? Here, what it will do? It will do shallow cloning. That means here Rakesh is a string object. So reference variables, both the E1's reference variable, E2's reference variable will be pointing to the same object only, as we saw in the diagram, right? We saw in the diagram, right? This diagram. So both names are pointing to the same. Can we prove this? Can we prove this? Yes, we can prove this. Simple. I will get name from E1, okay, and I will do the reference comparison. E2 dot get name. If I see the reference comparison, if it returns true, then both are pointing to the same object. If it returns false, then those two objects are different, right? If you see this, it should return true if it is shallow cloning, right? Yes, we will run and see. Yes, we got true. That means it is performing shallow cloning by default, right? So this is what we need to understand here. Okay, and you know, here there is one advantage. I will show you now. So let's say if it is, what is the problem with the shallow cloning? If for example using this cloned object, if you modify this one, right? If you modify this one, the original object also get affected, right? But affected, when it will be affected? When this object is mutable object. If it is changeable, if I change through this reference variable, this original object will get affected. But what is the object in this case here? It is a string object. String is immutable by nature, right? So if you try to change the object through this reference variable, it will create a new object, right? It won't change the existing object. So that is the advantage of using immutable objects while cloning. I don't need to write some specific logic for that to deep clone it, but even the shallow cloning is safe in case of immutable objects. So we have to remember, shallow cloning is safe in case of immutable objects. I will tell you, I will prove you now. Let's say if I try to change, what I will do is, I will try to change employee 2's, employee 2 is there, right? I will try to change his name, let's say. Okay, what will happen, we will see. E2 dot set name, okay, I will change it to some Mahesh. So what will happen now? Let's print and see. E1 and E2 again. I am removing from here, I am just printing here. Now see, employee E2 got only affected, employee E1 is not affected. We are safe, right? Even though it is shallow cloning, because of immutable objects, we are safe to do shallow cloning. But if, for example, if string is mutable object, definitely here this first one object, the first object also will get affected. The original object will be affected if the string is mutable. But thanks to Java, they made it immutable to make it reusable, and also we are safe. If you deal with strings, it is okay to do shallow cloning. So when deep shallow cloning will show the effect, I will tell you in other example anyway. Okay, so we are good this, right? We are good with this, right? Shallow cloning you understood, right? So shallow cloning is nothing but only the reference copies variables will be, only reference variables will be copied, but not the objects, nested objects. Okay, that's what we need to understand. Now this cloning is done, right? Is easy. Now we know how to clone it, right? So for cloning it, what we have to do? We have to implement clonable, and also we need to override the clone method, and we can call the superclass clone method. No need to do any other extra work. Okay, this is fine, we are good with this. Now let's say I have an employee class. Now this employee has some address also. Okay, I have created this for you to save some time. This is depending on address class. Okay, completely it is depending on the address class. Let's say address is mutable, we can change the address, right? So in this case, how we can clone it, we will see. Okay, let's say how we can clone this employee class, we will see. It has some reference variable which is mutable object, address is mutable object. So in this case, we will see how we can clone it. In real time, we will have this kind of scenarios. You may get a requirement to clone this address object, I mean this kind of employees with these kind of objects which have reference variables pointing to some other objects which can be mutable, right? So we will see this. So we will take another employee with address, E1 equals to new employee with address, employee ID, let's say Rakesh. Let's move it to the next line. Yeah, so this one I can pass the address, right? Address will take some city has some Hyderabad, and some state it will take, okay, state as TG, let's say Telangana. Okay, done. Now I want to clone it. Okay, this is a new class. In order to clone, what we have to do? First we will implement it. It has to be clonable, right? Clonable, right? Implements, right? Implements clonable. So this is one thing, and also we need to override clone method, right? Clone throws clone not supported exception, right? I am adding the override annotation also to make it safe. Yes. Now what we can do is just we will do the shallow cloning here also. Return super dot clone method. We have to typecast it to employee with address. Done, right? Now what I will do is I will clone it. Okay, how I will clone it? I will take another variable here, E2 equals to E1 dot clone. We are good. Now I will show you E1 E2, just we will print and see. Yes, this is E1. We have some employee ID, name and address. Address is having city and state. Here also the same objects duplicated, right? We are good. Now tomorrow, yeah, anyway, we copied this E2, and on E2 we will be doing some changes, let's say. Okay, E2 dot, let's say I want to make some change to the address. Let's say get address dot set city equals to, I want to change the city. I want to change it to Mumbai, and also I want to change the state also. Okay, E2 dot get address dot set state equals to Maharashtra. Okay, now what should be the E2 value, E1 value? We will print again. Okay, he'll just we'll add one line also here before changing. This is before changing, this is after changing E2. Okay, after changing E2, right? Now we will see what will happen. If you see this, after changing E2, this is E2. If you see the E1, this is E1. I am not changing E1, right? I am changing only E2. But if you see E1 address also got changed. Oh my god, this is the effect we have to understand. You know, right? It is by default shallow cloning we are doing. Shallow cloning, what will happen? In shallow cloning, this is how it will work, right? They will be pointing to the same object. If you take some other example, if you see this original object, cloned object, in shallow cloning, what is happening? This address variable pointing to the address object, city and state, and in the cloned object also, the address variable, reference variable is pointing to the same address object. Here we have not cloned address, only we cloned employees only. So the underlying reference variables are copied, but not the objects. So this is called shallow cloning here, right? So that's why this is, since address is mutable object, shallow cloning is not recommended. We must do deep cloning here. So after deep cloning, we need to have two address objects, one for original object and further cloned object. So two address objects we need to create in case of cloning. This is called deep cloning. In the deep cloning we do clone the address object also, right? So this is the effect we are seeing now. So for deep cloning what we need to do? So one option is deep cloning right here. So what we need to do in deep cloning? We need to clone the address also. How can we do it? So what we will do is address we need to clone first, right? So address equals to, we need to clone the address, right? How can we clone it? We can call the clone method again, right? But this address is not, yeah, it is implementing clonable. Okay, I made it already to save some time, and it is also implementing the clone method. So we can clone it, right? Yes, we can directly clone it. This dot address, whatever the current address is there, we need to clone that, right? So we cloned it. Now what we need to do? We need to call the super method to clone this employee, then we need to change the address only here. So what we need to do here employee with address some e1 equals to, if you take e1 dot set address, we change the address. Okay, now we will return e1, let's say here. That's it. So with this what will happen? We are doing the deep cloning now. We are actually cloning the underlying object also. So with this, if we run the same program, I changed the second object, cloned object, but the original object remain intact, so it is not changed. So this is how deep cloning is performed here. So this is called deep cloning. Okay, we are cloning the underlying objects also. This is how we need to do it manually. Even while doing manually also, we are making use of clone method only. So this is how we need to perform deep cloning, remember. So when we need to do deep cloning? Only in case of immutable, only in case of mutable objects. Let's say I have an immutable object. Let's say address is immutable. Let's say if this address is immutable, still do we need to do this kind of logic? That also we can check. This is very important. Let's say I will make immutable address here. Okay, employee with immutable address. I have created one immutable address class. So this is completely immutable class. You know, right, how to create our own immutable class. We have a separate video. You can check that how we are creating our own immutable classes. So here I have created immutable address class. So this will always, if you try to change the city, it will give the new immutable address instance with the changed values. If you try to change city will be changed. If you changed on the new object, not the existing object. If you try to change the state, it will be changed on the new object, not in the existing object. So this is immutable class altogether. So using this immutable class, if we do cloning, do we really implement deep cloning? We will check that now. So what I will do is employee with immutable address I will just perform. Here I will implement clonable. Okay, and what we have to do? We have to override, right? Public employee with immutable address clone throws clone not supported exception, right? To make sure whether we are overriding properly or not, I am adding the overriding annotation. Sorry, override annotation. Excuse me. So what we can do is return super dot clone method, and we need to typecast it. So we are good, right? Yeah. So done. So immutable address also, immutable address I don't clone it, but immutable address is clonable here, but it is not required because this is immutable, right? I don't need to do anything here, so I won't clone it. I'm removing this clonable. Observe it, immutable address. I'm just removing this. Sorry. this is employee class, right? And if you check the immutable address, anyway it is not implementing clonable, so okay, fine, because I don't want to clone immutable address because it is immutable, so no need to clone. So we'll see practically how immutable classes are helping here to reduce our work. So this is done. Now I will change this one to immutable. Okay, employee with immutable. Okay, immutable. This is immutable address. Okay, so after that I'm just cloning it. Employee with immutable. Okay, cloning it. After cloning it, see in employee with immutable address, what kind of cloning I am doing? I am doing what? Shallow cloning I am doing, right? I am not doing deep cloning, remember. With this, if you run this, immutable address, right? Immutable address, how we have to change? I am unable to change it. See, get address dot set city Mumbai Maharashtra, is it changed here? No. So this is not way of changing immutable address, right? So what we have to do is, I have to get the address here because it returns the new address, right? Immutable address addr, let's say 1 addr. Okay, and again addr equals to e1, right? So once you try to change the city, it will return a new address object, so it is returning. So on this address object, again if you try to change state, it will return again one more address object. This address object we can set to e2 dot set address equals to addr. So this is how we have to change the immutable objects, right? Because they are not changeable. So now what will happen, we will see. See, only e2 object got changed, the address got changed, but not the e1. Now with immutable objects, I am able to clone it with shallow cloning, and if with shallow cloning also, if I perform any changes on the cloned objects, there is no impact on the nested objects like address objects. So here in case of immutable objects, I no need to do deep cloning. This is very important point. With immutable objects, we no need to perform deep cloning, shallow cloning should be sufficient. So this is one of the advantages of immutable objects. So this is what you need to remember. I had worked on one project, that is a banking project, where each and every model class we created immutably. That means using some builder pattern we created. Once the object is created, we cannot change it. We must create a new object only with the changed values. So those are immutable objects. In the entire project we used immutable objects only. That is the pattern we followed. So whenever we want to clone it, it become very easy for us. We no need to implement deep cloning logic there. So that's how it reduced our work there. Shallow cloning will do its job. Because in the shallow cloning, what will happen? It will just copy the reference variables. The underlying objects will be like that only. No problem. We are reusing the objects. Whenever we want to change the underlying object, it will create a new object for that. So underlying the old object referenced by the original object will be remain intact anyway. Now new object will be referenced in the new cloned object. So that's why what will happen? We are safe. No need to implement the deep cloning there. With immutable objects, shallow cloning will be sufficient to reuse the immutable objects, right? So this is called immutability. So we need to understand immutable objects. With immutable objects, our job of cloning will become very easy, right? So what we learnt in this video, we learnt what is cloning, how do we do cloning, And what is the importance of cloning? Without cloning, it is different. Manually doing the task is difficult for us. That's why we have to use the clone method provided by object class, and that clone method is a protected one. We must override that, and we must implement clone not supported exception clonable interface, which is mark interface. Otherwise we will get clone not supported exception, right? And also with immutable objects, our job will become very easy while cloning, because for deep cloning we no need to implement our custom logic to clone the nested objects. With immutable objects we no need to write the logic for deep cloning, right? These are the things we learned. Okay, thank you for watching. Please like, subscribe, share it with your friends, and also please subscribe for more videos.